fall asleep now. So hopefully you're here for the right session. It's on the thing as flight mode, but sorry, airplane mode, but I've been calling it flight mode and didn't realize that that's actually how I originally submitted it. So it's nice and confusing now on the slide deck. But what we're going to be talking about is taking web applications offline and the data that you could be dealing with inside of those applications. So, hello. Hello. Yes, thank you for honoring my joke. Oh, hello. Sorry, this. I can't see that side of the slides anyway. I'm Aaron Powell, or Slace on Twitter. I blog at that location. I work for a consultancy called Redify. I'm an IE user agent and MVP, and yes, I'm Australian. Well, that didn't really work. Definitely don't have Hanselman's delivery methods down pat. Okay, so I want to tell you a story. I've got this idea for an awesome web application. It's going to make me rich. Like we're talking hundreds of cents, like tens of dollars. I'm going to be swimming in pennies. But it's using all the latest technologies. Like I'm using Backbone and Angular, it's spas and web APIs and REST services and Node and Knockout and event emitters, like everything, all these really cool technologies that everyone has been talking about for the last few days. And I've got them all inside my application. It's amazing. It's all well and good until someone flicks this switch. So this is not particularly uncommon. I mean, I came, as I said, from Australia. I got on a flight at 1:25 on Sunday afternoon and got off a flight in Dallas at 1:40 Sunday afternoon. It doesn't sound right. Yeah. But yes, so airplane mode, like if we're targeting, say, Windows 8 devices, this is a really easy thing to access and take your applications offline. All phones, it's obviously a requirement for them that they've got airplane mode switches with inside of that. So what do we do with our applications when they go offline? What do we do with the data that someone could be entering to our application? This is the most common scenario that people have with their applications. It just falls over. I'm sorry, that's not my problem. You've gone outside of the scope of where I've expected you to work. You've taken your application offline. I can't do anything more about that. It's not really a great experience for the users, though, is it? So that's what we want to talk about. That's what I'm going to be talking about for the next hour-ish, or however long I kind of lock you in this room for. So without further ado, the first thing I want to just quickly touch on is knowing that you're actually offline. So how do you know that your application has gone offline? It turns out it's actually really, really hard to know when a web app is offline. So this could be something that's like pinned to a start screen on an iPhone, or it's a tile that you added on a Windows phone, or whatever the equivalent concept is on an Android. I'm not familiar enough with Androids to know whether or not there's some equivalent concept, but I'm sure there is. So how can we actually work that out? Yeah, as I said, it's really, really hard because your network is disconnected, so you've turned the flight mode switch on your device. Is your DNS down? Are you just connected to a really poor conference level Wi-Fi? Is your ISP down? So you've got valid DNSs, but maybe your ISP isn't then being able to route you out. Is the host that you're trying to connect to offline? Is their hosting environment offline for some reason? So even though that we can get through our ISP, we can resolve the DNS, we finally get to their server, and their server isn't where they say their server is. It turns out that the W3C actually can't agree about how to do this. So there was at one point, there was navigator.online. It's got a capital L for online. That's in most of the browsers. In all the browsers, it will pretty much always return true. It's next to impossible to make it return false in all browsers. It's actually not possible to make it return false at all within Chrome. Chrome will simply just never say that it's offline. Firefox, you've got to explicitly go through the menus and select working offline for that to become false, i.e. when you disconnect a network connection, so when you do flip to flight mode, when you pull your Ethernet cable, you unplug your Wi-Fi modem, anything like that, it will immediately go into returning false for the online property. It will also trigger an event. That was something that was also proposed at one point in time. There's a network change, or no, online as an event, I think it was, that was fired, but none of the browsers could agree whether that was actually a good idea because of all these reasons that I've listed. There's different, offline can mean different things in different scenarios. So there's no, the standards body was just like, yep, we can't come up with a good consistent way of detecting that, so we're not going to put it into any of the specs. So let's assume for the point of this talk that we're just offline. That we're not worrying about how we're detecting that we're offline, that we're just always going to be offline. Working out whether you're offline, that's an entire talk on its own. And I want to talk about what happens to your data when you're offline, rather than actually working out when you're offline. If you are interested in trying to work out whether or not your application is online or offline, that's a link that the slide deck will be available after the talk. It's actually available now, but I'm not going to tell you the URL, so you've got to stay till the last slide. But that's a link to an example that was actually used in a demo, used in a talk yesterday, I believe, for detecting whether or not you're online and offline, and actually going through the different states and working out some of these different things that I've mentioned are really hard to work out, and going into a final offline state. So that'll be a good resource if you to do the kind of the final end piece to this scenario. So now that we know that it's really hard to go offline, but at some point our application might be offline, and if we're using app cache, like the mobile site for devLink is, we're probably going to want to be able to store some data, or deal with the ability to store some data. So let's start looking at some of the options that we've got here for that. First one is cookies. I'm just going to talk through my bullet points because you're only getting about half of them. That's kind of annoying. Oh, is it just no? Hang on a sec. Let's just drop the resolution down even further and see if that's any better. Yep, that's better. We'll actually see everything, even if it's just painfully small. Oops. Okay, yay, cookies, yay. So cookies, as was mentioned in the keynote on the first day, they're kind of like the oldest thing that was done to be able to track users, and that means that we can also use it to track when a user isn't online. So cookies have been around since Netscape 1, sort of like the mid-90s. It was first introduced. So unsurprisingly, they've got really good browser support. Of all the different storage types that I'm going to be talking about today, this is the one that will give you the best browser support. That's not necessarily a reason to use it, but it's going to have the best browser support. They're also part of the standard HTTP header. So when you write something to cookies, then eventually your application will be going online and you will be sending requests back to your server. So that data will immediately be sent back to your server. So if you're running some kind of a heartbeat, something to detect whether you're online, offline, and you can have as part of that heartbeat handling for the cookie and go, oh, actually there's an offline cookie, so let's pull that data out and deal with that ourselves, rather than having to explicitly sync the data later. So if you're putting a backbone out using backbone sync at a later point to then connect that back to your backend storage. And also the fact that cookies can expire is really powerful when you're talking about storing data offline. If you're storing offline data, you might not want to be persisting that permanently. You might want to have that as only there for the next 24 hours because the user is going to be, that's all you want it there for, or you want to persist it for a lot longer. And when you're offline, it's going to work a little bit different because you're not doing requests quite the same way. but the fact is that when you do come back online, that data can be previously expired. So it does have that advantage from the point of view of cookies. So, cookies! For the purpose of this talk, I've got a very simple sample application. It's a concept that it's probably going to be very foreign to most people. It's called a to-do app. Right. So bear with me. I'll try and explain what a to-do app does, and then we'll go into it. So this is using to-do MVC, which is open source project of implementations of different libraries and how they can be used to do to-dos. And what I've got here is a couple of couple of things that I should have done. I've done writing the talk. Yes, I think I ticked that one off. I don't know. Have I been awesome? Can I tick that one off yet? Maybe I'll wait till the end. We'll work out. But yeah. Oh! I see someone already giving me the end. Nah. It's going. Yeah, tough crowd. Last time I come back to the States. So to run this, I've written a little API. Start with this first tab. It's a little API called flight mode. So this allows me to create a storage mechanism. So I give a name for our data store. I tell it which adapter. So this is an adapter or provider-based API. So I can have providers for different kinds of offline storage, and that's what we'll be looking at as we progress along, making different kinds of storage adapters to be used inside of this API. And all it does is kind of your simple CRUD style operations: create items, remove items, get alls, things like that. So the get all and the get by are kind of the two that will be most interesting from what you want to do. So a get all, as in we want to get all the items out of our offline storage model, or we want to get an item by a specific key, so some kind of a unique identifier. So not necessarily a unique identifier, but some kind of a filtering property on that. So think of it kind of like a SQL where clause or a filter operation inside of a jQuery JavaScript array. The HTML is really not very exciting, so I'm just going to do that. And what I've got here is this is the application itself. So this is shared across all the different implementations. The code will also be included with the slides at the end, so don't feel like you've got to be trying to copy down all this code. There's quite a bit, and I'm probably just going to quickly scan through things and ignore them for you. But some of the useful parts is, so up here on line 4, the first thing we do is we create a new instance or a new store called from flight mode. It's just called to-do MVC. I'm not passing in a particular adapter because what will happen is it will fall back to the default adapter if I don't provide something specific. So when I register my adapter, each one registers itself as the default adapter. Feel free to take that as a bug in the way the adapters are designed. That if you add them all to the same page, they'll just keep overriding the default adapter to whichever one is last included to the page. But it means that we've got this generic app that we can share across all of our different implementations. So when we hit the enter key on the new item text box on our to-do app, it will then push a new item into our storage model. So this will push the new to-do item in there, just passing in two properties: the text for the item, and then a complete status of the item, which can then be used with some CSS and to put the little checkbox and things like that next to it. I also have the ability to refresh the list of items on here, and depending on the kind of state that I'm requesting for. So if I don't request for any particular state, I just want all the items. Otherwise, so that's on line 24. It'll call out get all operation on our flight mode storage API. Otherwise, I can pass in a state and get by a property of the objects within inside of our storage model. So here I want all the items that are in the status of completed or a status of incompleted based off of the state flag that I'm passing in. Then I'm just doing some mapping to convert them into HTML elements that you'd probably do better in templating and all that kind of stuff. So I'll quickly skip over that so you don't see my bad code. And lastly, we have a change handler. So when you tick checkbox, it will then go and update the particular item inside of the storage model. So I've kind of been lazy in the way that I implemented this. While I said that flight mode is a CRUD API, it actually doesn't have the U, so it's a CUD API. So I was debating whether or not to implement that, but ultimately I got lazy and didn't. That's an exercise for yourself, is to work out how you would be able to do updates on top of the API if you were so inclined. So here I'm just going to be removing the item based off of the ID and then adding a new one that has the status changed. So that means that this is our cookie implementation, and say blue. So that will add a new one here. You can check that. It will then change the state. So all these kinds of things, and as far as my application is aware, it's not connected to any kind of a server. I'm not needing to sync some data up anywhere. So the way this then looks is, if I just come over to the resources tab, you'll see that I have a cookie in here that's called to-do MVC, so the name of the store that we started with. And then hanging off of that, I also have a whole bunch of goods, and inside of those we have the value which has been our to-do item that we've passed in. This to-do MVC, it's not particularly readable there. Let's just drop into console. So it's got, here it is, this last one. So it's got an array which has got all of the keys that were previously added to this, so that we can. So we've got one which is essentially tracking all the IDs of the objects in our store, and then another cookie which is each unique item that's been put in there. So the way that works, find it. So I've got some simple create, read, and remove cookie from Quirks mode. I'm sure that anyone that's done enough front-end web development will have at least 10 times written a create cookie method. That's something that's very easy to find on the web. Same with the GUID generator was actually quite easy to find on the web. So unless, does anyone want to know how to create a cookie in JavaScript? Cool. I'm glad that we can just kind of skip over that. So the way this adapter works, we create so we've got our constructor function. We create we pass in the name of the store. It will attempt to find a cookie with that store name. So that to-do MVC cookie that we've got at the end. Kind of store that locally, deserialize it from as JSON, so it becomes an array that we can then interact with. Things like the add method will then generate a new ID. It will then assign that to the object in the store. Add that as a cookie itself, which we've got to serialize to JSON because cookies have to be strings. We will then also add that ID to the list of IDs that we're understanding within our store. All these kinds of things that are very tedious, and we can wrap away nicely behind an API like this. Remove, we just locate the cookie within inside of our cookie list by the ID. Erase that cookie. We then remove that from the list of IDs that we're tracking with inside of our JavaScript array. The get by is where it starts getting interesting. So here I'm actually using a pass through to the get all method. So we get all the cookies back out. We then do a filter on top of that to locate an item with that property of it that equals the value that we've passed in. So because these items have been deserialized from JSON, which is part of the get method. So get all calls get for each cookie and maps and all that, those kind of things. So we have to do a kind of a post-processing on this. So we start off by finding all of the data in our data store. Then we have to filter that ourselves before we can return out our subset. So this is kind of some tedious overhead that you would have to do if you were using cookies as a storage model. So cookies, you can store, I think it's a maximum of 4K for cookies. And that, whoops, that segues nicely into my next point, that there's always going to be some kind of a price that you got to pay, regardless of what storage model you're using. And cookies has got quite a severe price. You're adding weight to your HTTP requests. If you're not like proactively clearing the data out of your cookie store between like when the app's offline and you're storing data into it, and you're not then clearing it properly when the server comes back online and stuff like that, you are adding weight to your HTTP requests. So while it's a maximum of like 4K on a mobile device, that kind of thing is really, it's the kind of thing you don't want to be burdening users with. So the cookie API as well it's kind of a crappy API to work with. It's like like Nicholas said the other day, it was written for the first version of Netscape and pretty much hasn't changed since then. It's just a big long string that you have to like slice out of and like pull the cookies out of it. So it's a really crappy API to be working with. There's also like cookies are notorious for being like considered horrendously insecure, and they're used to track you, and they'll like all the NSA people will be using that to totally track you because that's going to be the most easiest way to track someone around the internet. I don't know. From Australia, we don't really understand this whole NSA prison thing. It's just like it's something that keeps popping up on like Reddit, and I'm like, I think I need to understand that, but no one in Australia talks about it. Cool. I'm just going to plead ignorance now, and I'm sure that works really well. Yeah. But there's definitely security concerns when you're using cookies as a way of storing data offline. The kind of thing that if you've got other scripts have been injected into your page, they're going to be able to read that data. You can do some intelligent things like if it only in HTTPS mode are these cookies valid and stuff like that. But still, like ultimately, I wouldn't be using cookies as a offline storage model unless I really had to. Like, it was the only thing I was supporting some kind of weird lowest common denominator like an IE3. And I don't think anyone is doing that ever. Another problem is it's actually a synchronous API. And as I said, this is manipulating a string on like the document.cookie property. I kind of blitzed through the code base because ultimately I don't think it's very interesting using cookies as an option. But so we didn't really look too deeply into how to do this. But it's a synchronous API, which means that the more data that you're storing, the longer it's going to take to do things. Like if you think you have, say, 100 keys or 100 items that you're storing, you've got to do it, and you want to do a get by. So you've got to deserialize all 100 items out of the cookies. First off, you've got to deserialize all the keys. Then you've got to deserialize all the items from those keys. Then you've got to filter through that collection to do the equality statement to work out the subset of data that you want. And while it might not seem like that's going to be a really intensive operation, it's still time that your application is spent doing things that you probably don't want it to be doing. You don't want to waste time deserializing objects, doing things synchronously, which means that you are blocking the UI thread in your browser. So let's move on to the next level up from using cookies as a storage model, and this is web storage. It's probably called, you might know it as DOM storage, you might know it as HTML5 storage, but ultimately this is what local and session storage are. So these are actually really common as far back as IE8. So it's a very accessible storage option that's available within inside of browsers. Local storage is the ability to persist something in a browser for an extended period of time. It doesn't actually have an expiry concept the same as cookies do. The only way to remove stuff out of local storage is to either remove it from code or obliterate the data, the offline data of your browser. Most browsers have the ability to go somewhere in the settings and choose to clear out your offline data, and that will remove local storage. So it's got the disadvantage of not being able to expire the same way as cookies can, but it's a lot more. It does also give you the ability to persist data for longer periods of time without those same concerns. Session storage, on the other hand, Session storage, on the other hand, is it's persistent for the lifetime of the browser with its connection to the server, I think. No, sorry, not connection to the server, just with its like the lifetime of that browser instance. So as soon as you close the browser instance and the browser deems that your session has been terminated, so things like Chrome and Firefox are a little bit looser about this than IE is. IE is kind of like you close all your tabs. That's when your session is terminated. I've seen instances where Chrome will kind of hang around to that a little bit longer, so it doesn't clear out quite as quickly as you think it would. But it does have the ability to kind of write data that is then expired in a reasonable time period. It's not something that will be persisted for infinite time, essentially. So you've got kind of those two choices, and you work out which one's going to be the best fit for the kinds of data that you want to be storing and the kinds of offline that you need to understand. Ultimately, I've not really found much of a use for session storage itself. I tend to fall to local storage because of the ability to persist between browser crashes and things like that. It's a lot more useful API. It's a key value store, so kind of like cookies where we were writing things to and from them. It's just a bit more advanced, so we actually have a specific API to write values to local storage based off of the key and read them back out based off of the key. The only downside is, like cookies, these are string-based, so we have to serialize everything to JSON before we can push it into local storage. I'm not actually sure about the size restrictions. It differs between browsers what the size restrictions are going to be. I think most of them are kind of around the 5 meg mark, but some browsers will allow you to push beyond that, and then they'll prompt you. IE and Firefox will definitely prompt you if you're going to be exceeding the amount of allowed memory that they've got. Like we saw in Scott's keynote yesterday, where it prompted saying that that it wanted to use more than the allowed storage, and then it's up to the user to kind of opt into that. But still, that's kind of a side point where once you're starting to hit like 5 megs worth of data that you wanted to store, you've got to kind of rethink the way your application might be working storing data offline. So it's time to web storage demo all the things. So we'll use our same code base here, and I will just swap over to new called web storage. There it is. So this one I actually haven't put anything in yet. There we go. So it works exactly the same as our cookie storage example. Chrome has the nicety of allowing us to inspect that. So here, I've kind of done it in this similar concept to the way that I was doing with the cookie. So we've got one that is of a known identifier. So this is the to-do MVC, the same as so what we passed in to the kind of the first line up here, and then that is then an array of all the IDs that need to be understood within inside of the storage model. It means that you could potentially create multiple stores and have them, like, they're going to have unique keys within inside of them, and there's one point that you go to and say, what are all the keys that you understand? Let's get them out, and then I can work against them. So, like I said, this has got local and session storage have quite a nice API to work with. They both inherit from the same DOM level API, so you don't need to do continuous checks to work out, am I working with local storage versus session storage? What you can do is your app does a deterministic branch to work out which of those types of storage you want to do, push them into, say, just a local variable called storage, and you can easily change between the two and not have to rewrite your code to target local storage specifically. You just change which variable you want to work with. And that's the way this example API is actually written. So when it sets up the adapters, it passes in the type of storage that we're going to be working with. We've got our GUID generator up there because, again, this isn't necessarily designed to act like a database, a data store of any kind. So it doesn't have the ability to generate keys for you. You could use, say, timestamps. That's obviously one option you could do, or I just find GUIDs are a nice, unique way. Unless you don't want to use GUIDs that have previously been used. There's a Twitter account that a friend of mine set up called Used GUIDs, I think it is. So every time you use a GUID, you just do a curl request to this account, and it will then tell the world that you can't use that GUID anymore. It's been used by someone else. Really awesome. Sorry, question. Correct. So all both cookies or cookies slightly less, but local and session storage are tied to your domain. So if you've got multiple apps on the same top level domain but different subdomains, I'm pretty sure that it's restricted. So you won't get so if you've got foo.example.com and bar.example.com and you're writing data in different each one, you're not going to accidentally get data from bar in foo and vice versa. So yeah, as for a get me everything with inside of local storage, I don't think that there is a get all. I haven't. There's nothing I know of straight off the API. Most of the dev tools will, if you just do local storage in the console, they'll actually give you something that you can inspect. So that's kind of the only way that I know that you could quickly look at what everything that's in there. Chrome obviously has a really nice experience of showing it up in the network tab. I know when you type it into console, it will give you an expandable object, stuff like that. But to actually get just an item, so you've got storage.setItem and storage.getItem. That's the two cores of this API. So you pass in two things to this. First is the key for the item that you're working with, so you're getting or setting, and then a string that you want to store. So like I said, this is kind of the primary downside to this as a really accessible storage option is the fact that it's still storing strings. So everything has to be JSON, calling JSON stringify. My little flight mode API here, it abstracts that away for you. You don't have to worry about that. It will just push that down, so you can just pass objects in and out, and you can work correctly with those. But still, if you're working with local and session storage, you are going to need to work with JSON and push and pull JSON. So add is actually very this whole API is very, very similar to the way the cookie one works. It just has local storage to do the sets and the gets, as we can see here. So set item, the ID that we've generated, then the stringified version of the object that we've passed into our API. Then we also do the same thing to update our global key list. But it does still have the same problem that cookies have. If we don't have a way that we can get all items back out and pass in a filter so the browser doesn't filter to it. Interesting side note, this is actually implemented in Chrome as SQL under the hood, and Firefox. I think it actually uses SQLite under the hood. So it does have the ability to do querying, but the spec doesn't allow you to do that. You have to just read and write keys from this, which means that we have to do post-processing of a get all operation. So let's get all the values out that our pseudo database understands, and then we'll do a filter on top of that to then work out how to work with this data. But overall, it's a nice API to work with, local storage, and it does have a lot more advantages over cookies. So if you're needing to be able to store data offline, it's a really, really good option to do that with. But of course, there are going to be some downsides that I've touched on. So when you start getting to advanced usages, so you do want to have complex objects that you're storing, and you need to be able to query against those and different properties on those complex objects. That's where the API falls down. You have to do a get all operation and then do JavaScript array manipulation to work out the ones that you want. The expiry of records, I put this as a downside, but it's not it's not necessarily a downside. It's kind of up to the way you're needing to work with it, to whether or not the ability to auto expire data is useful. If it is, then you need to consider, is session storage going to be beneficial for you? So that's kind of one option you've got with expiries. Again, it's also a synchronous API. While it doesn't have the same memory restrictions, the size restrictions that you've got with cookies, that we can store megabytes worth of data, that's actually going to start becoming a real problem. If you've got megabytes worth of data and you need to take a subset of that, you're going to be getting a lot of data back out. You're going to be querying over a lot of data. And this is all done on the UI thread. And you can do smart things with event loops and try and push those off, but still ultimately it's going to be somewhat limiting. You can potentially get some gains by pushing some of it into web workers if you've got web worker capability in the browsers, but still the initial hydration of all your records has got to be done in an asynchronous manner, and it's going to be blocking your UI thread. So it's definitely a downside if you're going to be storing large amounts of data. So now we'll get on to kind of the big daddy of our storage options, which is IndexDB. I'm a huge fan of IndexDB, and that was kind of where I based this original talk around. So IndexDB is the next generation of offline storage options with inside of browsers. For a long time, we heard about Web SQL was going to be how we were going to store data in our browsers, in like large complex amounts of data. But Web SQL is now officially dead. It's actually been officially dead for like 2 years. There's no browser that's actively implementing Web SQL. There's a couple of implementations still floating around, but it's not getting worked on. If you go to the spec at W3C, it's got this big, huge banner that says, "No one is working on this spec anymore. We consider it dead." Rah rah rah. So I would not recommend using Web SQL in any application that's being built anymore. So what is IndexDB? IndexDB is essentially a stripped-down version of a NoSQL database inside of Chrome, or at least inside of WebKit, so Chrome and now Blink. It's built on top of levelDB, which is a small, highly optimized database that they've built based off of big data, or whatever their internal database is. It's kind of a stripped-down version of that. Inside of IE, it's running off SNet, which is the same storage that's used behind like Active Directory and Exchange and things like that. Interestingly enough, Firefox still runs it off SQLite, which is what Web SQL is also implemented on top of. So Firefox is implementing a pseudo NoSQL database on top of the SQL database. So non-relational data inside of a relational database. But what's really useful and like really exciting about IndexDB are things like multiple data stores. So while we've seen in our 2 previous examples that we create a store and we pass it a name for this, when we do that with IndexDB, we actually have multiple little databases that we have, and each of those are isolated from one another. We have multiple tables within inside of those data stores. They're called object stores, but I'm from a SQL background, not a NoSQL background, so calling them tables to me makes that's how I understand it. But they're object stores. It uses the structured query algorithm to store the data inside of itself. So it actually stores a copy of the object that you pass in, not the raw object. So you will lose prototypal inheritance when you pass that through to IndexDB. But that's take it or leave it whether that's going to be a beneficial thing. You can also have indexes against your object stores. So if you've got something complex that you want to be able to query against, in our simple example here, we're querying against the completed property of the objects that we're storing. You can actually create an index to this, and the SQL people in the room, oh good, it's not common. You go, I often do this talk at JavaScript user groups. You go, SQL people in the room, and everyone's like, what's SQL? That's what behind the REST service, I think. So yeah, like the fact that you can build these, yeah, exactly. Give me a moment. So yeah, like I said, you've got the ability to create indexes, which can be really powerful when you start wanting to query complex objects, and this is then pushed into the underlying storage model. So SNet or LevelDB will actually be able to be optimized for querying against just that property. We don't have to hydrate all of our data to then push it into JavaScript array filtering and stuff like that. It's also got transaction support. Again, like, we've got enough SQL people in the room to understand why that is very beneficial. The fact that I do something that is transactional, which means that if one of the operations fails, I can roll back all the previous operations. This could be really good when you're writing complex, large and complex data objects into your data store. It's also transactional for pulling data back out as well. I see that as a little bit less beneficial, but it's definitely a plus, the fact that this is all transactional. It's also an asynchronous API. So if you're pulling out 100 records, it's not going to lock the UI thread. I'll jump over to our database in a browser demo. You see, cookies was really easy to find a funny image. Like web storage and IndexDB, I'm like, oh man, I'm gonna have to make something on QuickMe. It's just not gonna have as cool an effect. It's not as cool as Cookie Monster. Cookie Monster's cool, okay. Okay, so this is our IndexDB implementation. So because this is an asynchronous API and not a synchronous API, I've actually had to change our flight mode app. So it's flight mode promises. So here I'm actually going to use the queue API for doing promises, so that we can do this asynchronously. I don't have to pass through callbacks or anything like that. We've got JavaScript people in the room that are probably familiar with the promise concept. It's a way of doing asynchronous operations. jQuery made it popular a few years back. Queue is just another implementation of the promise API. You can use this with, say, jQuery promises and stuff like that. So we create a promise, and at some later point we're going to resolve that promise either successfully or unsuccessfully, and we return that promise. So we then attach callbacks to the promise, and when the promise resolves, it then tells the executes the appropriate callbacks. So as I said, there's some changes to the way the flight mode API works. So the first thing I need to do is I'm passing through a callback for when we successfully open a connection to our database. So the recommended usage of IndexDB is you create one connection per page. You don't shut down your connection until the page, either the user explicitly needs it shut down, so they've clicked some option which you've told which indicates that they want to close their DB connection, or they're navigating away from the page. So we start the connection up as soon as we need it. So and we keep that around in a variable that's just hanging out the window because that's the best place to store it. Wow, everyone didn't disagree with that. Whoops. Then the second callback handle that I've passed in, so here on line 10, so here I'm passing in a callback that I'm then getting a store. So the store is actually the raw IndexDB object, and from here I'm allowing consumers of my API to actually manipulate IndexDB. In this case, I want to create an index on the completed property, just with the name completed. So the first argument is the name for this index, and the second is the property of the objects that we're going to be storing, that I want the index to be looking at. You can also do some other kinds of indexes, such as composite indexes, where you have two or more properties of an object that you want to be able to index. That doesn't have as good a cross-browser support as just single property indexes. IE doesn't support multi-key indexing properly, so use that with caution. I tend to avoid using that. I would look at if I needed that scenario, if I needed to do multi-key indexing and I wanted to support IE, I would be looking at what is the property that I'm going to get the most data set reductions on, and then doing the rest of the manipulation inside of just a JavaScript array filter. It's a bit of a downside. I've raised the bug to the IE team, and they're like, whatever, bro. They don't seem to care, and I get very annoyed by that, and then I cry myself to sleep. So because this is now working asynchronously, I can't just, from adding a new item, I can't immediately then update the UI, like do a refresh and set and clear out the text box. I kind of want to wait until I know that I have successfully written that to the data store. So that's what I'm doing here on from line 20. So passing through to the promise API, passing through the first callback, which is on success, essentially. So when the promise is resolved successfully, I want to execute this function. So if I've successfully added an item to my data store, I then want to clear out the text box and refresh the list of items that are on screen. Similarly with the refresh items. So first off, I'll work out whether or not I'm going to get all or get by. That will then return me a promise, which I then add a success callback to of if I've successfully got items from the object store. So this could be 0 or more items inside of our collection. That's when I then want to do an iteration over the collection and start displaying it. I don't have the collection until this callback handler has executed successfully. Similar things further down can be done with adding and removing, but I just was quickly hacking this together and I'm like, I'm not going to do this all properly. So the way we work with IndexDB, the first thing you want to do is do a check against the different vendor prefixes. So IndexDB is so window.indexdb is going to be the API that you'll work with. Chrome up until version 21, I think it was, so that's actually now quite obsolete, was still prefixed. And same with Firefox, I think it was version 16 or 17, it was still vendor prefixed. So whether or not you still need to add the prefixes, probably not, but this is code I wrote a while ago and I haven't updated it since. So I just push that into a local variable called IndexDB that I'll then work against. First thing we do is we open the DB. So we have to give it a name of the database that I want to open. So this name, I've just got it hard-coded inside of this API. This is the kind of thing that you would have if you wanted to have multiple databases within inside of your application. You would open, you can open connections to different databases, but you can only have one open connection per database. So depending on the way you're architecting your data in your data stores within inside of your offline application, you can open up multiple connections like this. There is then the primary event you want to be listening for is on success. So when you do an open, it will return an IDB request object, and this is what's actually returned from all of the operations that you do against IndexDB. Because it's all asynchronous, they return you've made a request, here's the request object, add event listeners to that request. So here we would add an on success, so I want to know when that request is successfully completed. Is on error that I haven't implemented inside of here for brevity. But the initial open request also has an on upgraded needed event. Sorry, on upgrade needed event. This one is fired when we change version of our database. Something I haven't got up here in my sample, but I can specify the version of the database that I want open. This means that, say we've got an application that we've deployed, like version 1 of our application has gone out, we've been using IndexDB, we've been reading and writing to it, and now we've done some major updates, and our data store model has changed. So we need to change our IndexDB version because it needs to reflect the new version of our data store. So we would change this to version 2, and this will then trigger the on upgraded needed. And from here, we can manipulate the index store before the connection has been successfully completed and the database is ready to be used. So you can execute things like migration scripts. Other things you can do, such as what I'm doing here on line 19, is I'm creating an object store using the name that's passed in, so to_MVC. I'm also saying that there is going to be a key path. So this is our primary key. It's going to be called _ID_, and I want that to be auto-incremented as a key. So this means that I actually don't have to generate the IDs myself. IndexDB will generate those for me. You can set a non-auto-incrementing ID, non-auto-incrementing key path, if you had something else that you wanted to be unique, say an email address, and you wanted to use that as the unique identifier for data that's within inside of your data store, you can set that up that way and set the key path in that regards, and IndexDB will just assume you're giving it that property. If you don't give it that property, it will raise an error. This is also where you would want to do things such as modifying your additional indexes for an object store, those kinds of things. If you're doing version migrations, you would copy the data from the old database to the new database, all those kinds of things. Adding, this is where the API starts getting a lot more verbose than any of the other APIs that we've worked with. So I've got my connection to the DB, which is available as soon as the on success event is raised. That's when we have a successful connection, just assigning that back outside of to our store instance. So from our DB, we tell it we want to open a transaction and we want to give it a name. So I'm just using the store name for this transaction. We tell it what kind of transaction we want. Do we want a read-only transaction or a read-write transaction? Read-only is the default transaction type. So you don't have to pass in if you just want a read-only transaction. If you want to be doing any kind of data storage, obviously you're going to need a writable transaction. Once we've opened our transaction, we then have to open an object store. So the object store has to match the name that we created up earlier. So again, I'm just using this .name. And then we call the add method on our store. This will then return an IDB request. I've just been lazy here and not done any error handling and just immediately assigned the on success. But in a real world scenario, you'd be wanting to capture that request that comes back, attached to say, both the on success and the on error, do proper error handling and deal with it that way. I'm also, as I said, using Q to deal with the asynchronous nature of this. So create a deferred object inside of the success callback. I call defer.resolve and pass through e.target. So this is using the same style of DOM events that you would get from click handlers, change, etc. So this is just it's a DOM event object. So the target of the event is the data that's come back from IndexDB. But we pass through the result property of that. In the case of an add, that will be the key of the value of the key path that you set as the primary key inside of your index, sorry, inside of your store. So this will be the auto-generated ID that gets created. Lastly, I return the promise on line 39. That means that I can do .then in the consuming API. We'll skip over some of the other ones and look at where this starts really getting interesting with the start with get all, and then we'll look at the get by. So as I said, read-only transactions don't require anything being passed to them. So I'm not passing anything as the second argument to the transaction creation on line 71. We then have to open our store. Then create my deferred object. I then have to create a variable which will contain all the items that I'm pulling back from the query that I've done. I open a cursor. I am attaching to the on success from the IDB request. Then inside of the on success, we'll either get a cursor or we won't get a cursor. So that will be the result of v.target.result. So if we've got a cursor, it means that we found an item from the query that we've just done. So I have to push that into a collection outside of my closure scope, or console.logit if it's a real world scenario. I then have to call cursor.continue. Continue is actually the name of the method that you have to call, which is really crappy when you start working with linters, because linters like continue is a reserved word. So you'll see code such as I've got here all over the shop with IndexDB, because that's how you get around linters, is you use the square bracket notation to access the property on the JavaScript object, being the cursor, and then you have to invoke that as a function, and that tells the IndexDB that you want to then go to the next item that would be available from the query that we've performed. If you don't get a cursor back, it means that you've hit the end of the record set for that query. You're obviously not going to be able to call cursor.continue, because that's going to be calling a property on an undefined object. But it's kind of tedious. I find like the fact that you have to do this check every time kind of adds overhead to it. But the nice thing is this is done asynchronously, so you're not getting all the data back in one hit. It means that the UI thread is released. It will then continue on to say doing a repaint if you've got something else happening on the screen. Once it's capable of handling the request again, it will then move on to the next item in the cursor and so on and so forth. Once the cursor request is completed successfully, it will then do an on-complete of the transaction, and this is when it's done. This transaction is completed, everything went successful, so this is the point that I want to tell any consumer, here's the data, and that's why I've got to capture this the item collection as a variable outside of the scope of the on-success method. So you wait till your transaction is completed, and then you notify anyone that needs this data. You can do it, and I have seen it done in the on-success when you don't have any cursors left. Problem is that if your transaction is still open and you do something then with that data, it's because it'll be executing synchronously. At that point, and you try and then do another query into IndexDB, there's already an open transaction. You'll actually get a conflict, and your second transaction will fail, and all of a sudden your application's in an error state. So that's how you do a get all, is you just open a cursor straight off the store. But what if you wanted to get by a particular index that we've created? So all we really need to do is add an additional line to this, so line 96. So instead of calling store.openCursor, I've got var index equals that's really good coding. But we call store.index and we tell it what index we want to open. So this is where I pass through completed. So I want to open the completed index. And then it's just, so that's kind of the only line you would need to swap out between a get all and get by specific property. And this means that inside of our database, it's actually going to be doing that filtering. So our on-success method of our cursor doesn't need to care itself about the fact that it might get data that doesn't match the filter that we passed in or anything like that. The rest of it then becomes exactly the same as dealing with a get all operation. So that's where IndexDB starts getting really powerful, is we can start doing complex queries such as that. Yep. No, I think I've actually just broken my code. So it should be the second value is passed in as the value of it. Yeah. So I have actually forgotten to do that, and that makes my demo look really bad. Whoopsies. Yes, so you would normally pass in the value that you want for that index. I think the reason this actually works is because it's a Boolean. But yeah, yes, normally you would pass in the value that you want to filter on. So if we just quickly actually, don't need to jump over to the other one. Chrome is the only one that's got really good dev tools for this. So you'll actually see in the resources tab, here's the index. So here's the collection that I've created. I haven't got any items in there at the moment. I just noticed that we're quickly running out of time, so I'm going to start speeding up a little bit. But Chrome allows you to inspect the data that's inside of your object store, list off your different indexes, so you can look at what data is falling into which index and stuff like that. So it's got really good dev tools. It's the best dev tools available for IndexDB. Forgot those hyperlinks. Okay, so we're whoops. There we go. Okay, so as with everything else that we've looked at, there's going to be some kind of a downside, and the most prominent downside for IndexDB is the fact that it doesn't have great browser support. It's IE 10 plus, except for multi-range querying and stuff like that, which is more edge case than anything. But the real kicker is mobile Safari. Even with iOS 7, they haven't upgraded to a version of WebKit that is running IndexDB. they still ship with Web SQL out of the box. That's the only browser that is kind of like commonly found in production environments that is still using Web SQL. Conveniently, there is actually a shim that has been written for IndexDB on top of Web SQL, so you can use the IndexDB API in mobile Safari. So that's, I don't recommend you use Web SQL. If you do have to target browsers that use Web SQL, look for the shim and make sure that it is supporting all the scenarios that you need to support. I haven't played too much with the shim. From my understanding, is it does everything that you're going to expect it to do, but yeah, it's building a non-relational data store on top of a relational data store in JavaScript. Can't see what could go wrong. In my opinion, the API does suck. Like the fact that you've got transactions that you're continuously creating and trying to get people that are coming from a purely front-end background to really grasp this idea. The idea of transactions and indexes and cursors is really foreign to them. So it's very verbose. You end up having like 20 lines of code to really, you're only trying to get items out of a store. It seems like a lot of code to write. So it can be a very difficult concept to grasp to people that are not from a slight server-side background. And for really simple data, it's the wrong choice. If you just need to store like a couple of keys and it's not consistent looking data, don't use this. You're going to find you've got a lot more problems. Something like local storage is going to be a much better scenario. I meant to mention, Twitter actually uses local storage. If you use the Twitter web client and you start creating a new tweet and then you hit like escape or refresh or anything like that, have a look at local storage. That tweet that you started writing is there, so you can create it again. I only noticed that because I was like, no, I didn't want that tweet. Why is it still there? And found it in my local storage. I was like, oh, cool. I don't know anyone big using IndexDB. I've seen things on the W3 mailing list of, yeah, I'm like storing 100 million items in it and it's crashing. It's like, cool, but that's a lot of data. So yeah, it's got very specific scenarios that it's trying to target. Okay, so it's been really cool talking about these storage models, but how do we actually add this to our systems? So my suggestion is you make everything a promise-based API. So where I added promises to the flight mode version that is running from IndexDB, you can also simulate asynchronicity with the other storage models. And you just use a set timeout at 0, and then inside of that do the actual operation and then call resolve, or just immediately resolve the promise kind of in line. So that's how we would use it. There is a demo in the slide pack, but I'm running out of time, so I'm going to skip over that. What I would recommend doing is, once you've made your APIs promise-based, start writing both to a storage model and to your REST service. This way, if your REST service falls over, or your AJAX service, that way if it fails, you've still got the data that's being captured that you can then later go back and reissue that request with. If it's successful, cool, you just can remove it out of your storage. That's the easiest way to kind of add this to an application that you've got some kind of a form that you want to submit, and you want to make sure that you are definitely capturing the data, and if it crashes or if your service is down or anything like that, you've still got that data around, and you can pre-populate the form when the user comes back to it. You can notify them the next time that they're on the site and say, hey, we saw that you got this file last time. Do you want to load your state? Things like that. As I said, there's a demo, but I've only got about 15 minutes. There's a couple other things I want to jump to. So check out the slide deck at the end, or the slide pack at the end, and that demo will be in there. So we have the technology. We can rebuild it. But I don't want to spend a lot of money. I'm a Family Guy, like massive Family Guy nut. No, I think that's one of the funniest things. I've never seen the $6 Million Man. I'm not that old. And the only reason I get the reference, and the reason I can put it in is because I watch Family Guy. Yeah. So I want to talk about a couple of libraries that we can use. We don't want to rebuild these every single time. We want to be using existing libraries for this. I figured I probably should talk about Amplify Store, and I actually think all the Amplify guys aren't in this room, so we can rag on it as much as we want. So Amplify was written by Append2. All the Append2 guys are gone, so I can just rip it apart. So, whoops, wrong window. Now, let me find the code. So, Amplify is an open source library. It's got a couple of different features to it. It's got some improvements to the way jQuery Ajax works, allowing you to better handle different kinds of request data. But I think the store API is actually one of the really cool things about it. So this has got a very similar concept to what I built my flight mode API based off of. So, excuse me. You'll see we've got amplify.store. It doesn't quite work the same as I did with my flight mode API. I don't have some kind of a specific storage model for one single database. It's not designed for that. It's just designed as a way to improve the way you work with local and session storage primarily. It's also got fallbacks to some other storage options that I haven't talked about, such as user data, which is for IE up to IE8, you'd probably use user data. It's got something that was only in Firefox 2 and will fall back to in-memory storage as well. But it's also adapter-based, so you can create your own implementations. So you could create a IndexDB version if so required. So what we do with this is we call amplify.store, and here we have to we have to give it the key that we want to store. So I've had to move the logic of generating a new ID into my app's code base. So I call amplify.store, pass through the object that I want to store. It will take care of all the serialization of the object. It does some additional things like it adds expiry capabilities to local and session storage. Under the hood, they just check the value isn't expired when they're trying to deserialize it and don't return you anything if it has against the current date of your browser. So it's got some very nice features about it, and like I said, it works very similar to my code. Interestingly enough, the way that you would do a get all operation is you just call amplify store and don't pass it the key, or you don't pass it anything. And this just goes, okay, you haven't requested for anything specific. Here's all the data that you want. If you want just a single item, such as we would be doing down here for updating, if you just wanted a specific item, I don't think I have an example of a specific item. You just pass the ID through. So it's very jQuery-esque of it's got one method that does multiple things depending on what you pass to it. So don't pass anything. It will just return you everything, but you're still going to have to write your own filter logic on top of it, as I've done here with the item complete. The biggest thing that I find is frustrating about Amplify Store is the way you remove items. So this is how you remove an item. You store the item with an expiry of less than the current date. Come on, guys, I just want .remove. That would have been so much easier, but no, because it's just a single function that you call. You have to pass it through with an expiry it's been and gone. That annoys me about the API, and that would be when I would be using this in a production application. I'd either be shimming it myself and adding a remove method. I think they did just tell me to send a pull request. It's an open source library. It's like, if you want to fix it, go out and do that yourself. Or I would create just kind of a wrapper around this to also then encompass things like get by style functionality. But it's a great option for doing work with local and session storage because it does a lot of that stuff that I talked about earlier. In fact, you got to serialize your data down to JSON. It adds the expiry capabilities to local and session storage, which can be very useful. Interestingly enough, it doesn't actually have any fallbacks to cookies, so I find it strange that they've added expiry capabilities, and yeah, it just never uses cookies. But all right, whatever. Okay, so that's a good option for working with local and session storage. If you want a much more well-rounded, kind of feature-complete generic solution, Lawnchair is a really great API for that. So Lawnchair is, I think I have, wait, no, I don't want to open up the Lawnchair API. So Lawnchair is similar to Amplify, as it's a provider-based implementation. The primary difference with Lawnchair is, oops, if I can find the right file. The primary difference with Lawnchair is it's asynchronous by default. So you need to, it's asynchronous by default, but it uses, you got to pass through callbacks. So if you wanted to integrate with a Promise API and do that style of callbacks, which is what I've done in my examples, you need to pull in something like Q or jQuery, or any other Promise library that's available. But yeah, it's adapter based, and it actually has adapters for things like WebSQL and IndexDB. So they're all available out of the box, and because it's designed to be asynchronous, it's immediately going to work with those asynchronous APIs. The only library that I know of that will do that out of the box is called CouchDB, and that's an implementation of CouchDB in the browser, and it has the ability to then immediately sync back. Because it's very difficult to create a generic API that would work with the syncing, what I would do is have some kind of just a REST service available. Depending on how many different types of offline data, you might have multiple APIs available, that when either you're looking at Navigator offline, or whether you're doing the additional work to detect coming on and offline, when that event fires, that's when you would then, okay, let's open my store, or notify to the user saying, hey, we've just noticed you've come back online. You've probably got data that you want to, like, we've got data that that you haven't synced back to the server. Do you want to sync that? And then just opening our data store and passing that straight through to AJAX requests. So I designed it in the way that the data that I push in to my storage model is in the same structure as the data that I send back to my REST service, which is then, it's just the same kind of API that I'd be working with if they weren't offline initially. One of the great things about JavaScript is, because it's a dynamic language, we can swap instances in and out. So if you didn't want to go down the route of, when we do the request, we also do a save, and if the request isn't successful, we'll leave the item there. Otherwise, we'll pull it back out of storage and remove it. You can swap the instance, so you would have a store object that pass through. This would work great for Angular app, because the dependency injection can take care of that for you. So you would go, okay, you're offline, so I want to return service. I want to return an instance of offline service. You're online, I'm going to return the online service. And it's just got a store method that you call, and you pass through some data, and it will then go and use the correct implementation based off of the state of your application. The initial idea behind this talk was working with Windows 8 applications, and they've got a different way again of detecting whether you're online and offline. It's just like a low-level Windows API that you can invoke in JavaScript. So some of I know that it's a really easy way to detect online offline in Windows 8 applications. Not necessarily in the browser. It's a bit trickier, but the ability to swap services in and out is definitely like that's kind of the end goal of how I've been working with on an offline storage. We're pretty much out of time. So, like I said, this stuff's going to be all in the pack at the end. One thing about Lawnchair is it has the ability to do querying and kind of pass through querying information. So here, what you can do is store.where, and then pass through a expression to evaluate, and it will do some smarts to kind of break that down. Generally speaking, that will still fall back to being a array filter, particularly with things like local storage as an option. I haven't looked super deeply into the IndexDB implementation. I think you have to set up your own indexes before it would work, before this can get passed through to launcher and be done as an index level query rather than just a get all operation and then an array filter. Obviously, if you're using IndexDB, you want to leverage its index capability to do your filtering. Last library that I won't show you is called db.js. It's just a wrapper on top of IndexDB. I read this, so it's the awesomes. And the whole idea initially behind this was I wanted to make IndexDB less verbose to work with. So it's got a more fluent, because fluent APIs are the cool way to write JavaScript, way of producing queries. It has a better way of writing indexes and object stores, and takes away a lot of the ugliness that I perceive the API to have. And that's in the download pack. As I said, my name is Aaron Powell. Thank you for coming. I'll be around for the rest of the day, and thank you for attending. That's the link to where you find the slides, and I'll also tweet them out. So yes, thank you for coming. And here I was worried that I wasn't going to have enough time to cover all my content.